Today I will be going over question A in homework 12. Question A in homework 12 reads, you are given two positive integers, n and k. Represent the number n as the sum of k positive integers of the same parity. In other words, find a1, a2, all the way to ak, such that ai is greater than 0, and n is equal to a1 plus a2 all the way to ak, and either all ai are even or all ai are odd. If such a representation does not exist, then report it. So, when we first think about this question, we want to figure out what parity is. So parity is a number and whether or not it is odd or even. How do we get an odd number versus how do we get an even number? Now let's say x is even, right? Then very simple. An even number is an even number plus an even number. For an odd number, if x is even, then x plus 1 is odd. What makes a number even? If you can factor out 2. In this situation, we can factor out 2, obviously, because x plus x is just 2x. Now, x plus 1 is an odd number. So, to get an odd number, we need this hanging 1. So we would have to add it by an even number, x. Now, there's another way to get an even number. X plus 1, so an odd number, plus x plus 1. Right? We have two hanging 1s over here, so we can add them. That's x plus 2, and then we factor it out, and that's why this is even, right? So let's go back to the problem. We are trying to figure out how we can add k numbers that are all either odd or even so that they equal n. Let's go into an example to figure this out. 10 and 3. So we need 3 numbers that add up to 10 that are all even or all odd. One way to think of this problem, because there's clearly many solutions, one way we can think of this problem is we can add the smallest of a given parity, k minus 1 times, and then add whatever is left to get n. So let's use this example. Just by the looks of it, I'm going to guess that it is even. Obviously, in our code, we'll have to set up a conditional statement to see whether or not this is going to be even or whether or not it's going to be odd. But because it's 10 and 3, the numbers are easy, we can guess that it's going to be even. So let's go 2, 2. So that's k minus 1, right? We have a 2 and a 2. And 10 minus 4 will be 6. So there you go. We have our answer. Three numbers that are of the same parity. They're all even, and they add up to 10, right? So that's going to be our approach for this question. Now, let's get started with the code. So first, obviously, we have to read in the test cases. So and then we need a for loop. So that we can keep gathering different n's and k's for each test case. Then we read in n and k. And now let's go with our logic, right? So let's start with an odd number. If we are going to get or if we are going to get an n with all odd numbers, then n has to be greater than or equal to k, right? Because if we're testing for odd numbers, then we're going to start off with 1 plus 1 plus 1, etc. till a of k, and when we get to a of k, we'll subtract the amount of ones we have by n, right? So let's go here, and now we have to see if the last number is also odd. How do we do that? We have n minus k minus 1, right? Like I said before, 1 plus 1 plus 1, all the way up until k minus 1. And we have to check if this number is odd. So right there. And we know that if something is divisible, if something is divisible by 2 and gives us 1 or not 0, then it's odd. One way we can do this is we can just check if n minus k is even, right? Because if n minus k minus 1 is odd, then n minus k must be even. So let's just do that. Shortens up our code a little bit. Now, if this is true, then bingo, we have ourselves an answer. So print yes, and now we have to get that answer. We have to print that answer. So I'm going to print it with spaces, and we are going to print a bunch of ones, right? How many ones? We have k minus 1 ones to be exact, right? So we're going to print that k minus 1 times. Let's put parentheses around that. And then we have to print the last value. And what is the last value? First, we have to cast it as a string. And what is the last value? The last value is n minus k minus 1. And let's just make sure that our brackets align. Yeah, it looks about right. So that is our odd logic. Now we have to get our even logic. So similar strategy. We have to check if n can fit 2 times, or 2 plus all the way to k. So we have to see if n is greater than or equal to 2 times k. And we just have to check if n is even, right? That one is self-explanatory. Let's check. See, we have to make sure that n is even, because that's the only way we're getting even parities. So if this is true, we're going to print. Very sorry, this is not how we check a value, right? Double equals, that is my bad. So if this is true, then yes, we have ourselves an answer, and then we have to print the answer. Let's just save ourselves some time, and we can take this value right there. We are not printing ones, we're printing twos this time. And is our string n minus k minus 1? No, it is n times n minus 2 times k minus 1. So these are our two options for answers, whether or not it is a parity of even or whether or not it is a parity of odd. Now, obviously, there is the last case scenario, if we do not have an answer, we are just going to print, oh, sorry, I forgot some colons. We have a lot of syntax errors in here, folks. Print, no. And that looks like it's everything. So, oh, we forgot another colon. So let's test it out. 10 and 3. Earlier we said the answer to that was 2, 2, and 6. So that'll be our one test case. And we'll go 10 and 3. Okay, this is a perfect example to try to help us debug a little bit better. So, yeah. Oh, so obviously in methods we need our parentheses. So once again, 10 and 3. So yes, 2, 2, 6. There you go. That's how we solved this question.